Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll solve two systems of nonlinear equations using the substitution method. In the first one we've got x squared plus 9y squared equals 9 and x minus 3y equals 3. Excuse me, the first one is set up to use substitution because we can solve the first equation for x in terms of y. X equals 3y plus 3, which I can then substitute for x into the first equation. Let's give that a shot. So instead of x squared, it's going to be 3y plus 3 quantity squared plus 9y squared equals 9. We need to multiply 3y plus 3 by itself. And sometimes we learn formulas, we memorize formulas to square a binomial like that. I think the safest way is to just write them next to each other and use FOIL-style multiplication. Plus 9y squared equals 9. Let's begin the multiplication. 3y times 3y, that's 9y squared. 3y times 3, that's plus 9y. I've got another plus 9y there, and finally plus 9. Plus 9y squared equals 9. That is a lot of 9s. Combine like terms on the left-hand side. 9y squared plus 9y squared, that's 18y squared. Combine the two terms of degree 1. 9y plus 9y, that's plus 18y. And then to get it into the form that we can use, I want to bring the 9 over from the right to the left so that everything's equal to 0, but 9 minus 9 on the left also equals 0. So we have 18y squared plus 18y equals 0. We can factor out a common factor of 18y from both terms, leaving us 18y times y plus 1 equals 0. From the first factor, we get a potential solution of y equals 0. From the other, we get y equals negative 1. Now we want to go back to the equation we used to make the substitution, x plus 3y equals 3, and substitute those values for y to get our values for x. So x would equal 3 times 0 plus 3. That is 0 plus 3, or 3. From the other solution, x equals 3 times negative 1 plus 3. That's negative 3 plus 3, or 0. So the two solutions are 3, 0, and 0, negative 1. However, we should check in the other equation to make sure that they both work in the equation at the top, which, by the way, is an equation of an ellipse, which we'll learn about in the next section. I'm going to begin by checking 3, 0 in that equation. 3 squared plus 9 times 0 squared, does that equal 9? And it does, because 3 squared is 9, and 9 times 0 squared is 9 times 0, or 0. And so that one works. For the other point, 0, negative 1, we have 0 squared plus 9 times negative 1 squared equals 9. 0 squared is 0. Negative 1 squared is 1 times 9, that's 9. And 0 plus 9 does equal 9. So both solutions check out here. There's the solutions. For the second problem, x squared minus 2y equals 8, x squared plus y squared equals 16. You may be thinking, well, let's try to get the y by itself, and we'll substitute that expression into y squared in the second equation. But here, we can actually solve this for x squared. X squared equals 2y plus 8, and then that can go in for x squared in the other equation. So let's try that. Instead of x squared again, that's 2y plus 8 plus y squared equals 16. And again, there's no square on the 2y plus 8. We're replacing x squared by 2y plus 8. Y squared plus 2y plus 8, writing everything in descending order, equals 16. Subtract over the 16 to solve this quadratic equation. y squared plus 2y minus 8 equals 0. We can solve this one by factoring. It factors to be y plus 4 times y minus 2. And our two solutions are y equals negative 4 and y equals 2. Now we can start with those solutions and find the value of x that goes with them. And we could really use either equation here. But again, I'm going to go with the one that we use to make the substitution. X squared equals 2 times negative 4 plus 8. That's negative 8 plus 8, which is 0. So x squared equals 0. And when we take the square root of both sides, including the plus or minus, this is simply x equals 0. So one of our solutions is the point 0, negative 4. For the other one, x squared equals 2 times 2 plus 8. X squared equals 12. X equals plus or minus root 12. X equals plus or minus 2 square root of 3. And those are the exact solutions. So 2 root 3, comma 2, negative 2 root 3, comma 2. You could also approximate those if you needed to by simply using your calculator. The square root of 12 is about 3.4. Well, let's take a look. Two times square root 3, which is the square root of 4. Whoops. 3.464 if we round to 3 decimal places. We should check these solutions in the other equation. So I'm going to go to the equation that was x squared plus y squared equals 16. And I'm going to start with the point 0, negative 4. So that's 0 squared plus negative 4 squared equals 16. And negative 4 squared is 16. 0 squared is just 0. So it does equal 16. That one checks. For the next one, I'm going to check the positive value of x, 2 root 3, comma 2. And if I use the fact that that came from the square root of 12, that's going to make my work a little easier here. Square root of 12 squared plus 2 squared, does that equal 16? Well, the square root of 12 squared is 12, and 2 squared is 4. 12 plus 4 does equal 16. I don't need to check negative 2 root 3, comma 2, because when I square negative 2 square root of 3, it's going to turn into positive 12. So that one works as well. So there's two examples of solving systems of nonlinear equations using the substitution method.